Hi everybody. Today I want to share a really exciting tool that will allow you to select any wall in your Revit project and then to split it into individual wall layers based on its materials, of course. That's a very unique tool, but I know that many of you really want to have this functionality in Revit, and now you can have it. I will also add this tool to my EF Tools extension later on, so anyone can use it without any coding knowledge. But also, I want to show you how to create such tool with Python in this video step by step. So if you never coded before or you're a seasoned developer, you will all benefit from this video by either getting the complete tool that already works or by seeing how to create it. Also, a quick note before we begin. I wanted to shout out Mohammed Bidir and Joven Mark from my Revit API community. Mohammed has started this tool and Joven was helping him in the beginning, and then in the end I've come along and helped Mohammed finish some issues, and then I've also rewritten the code to my liking. And now I want to share it with you, with your permission of course. But first of all, let's go to Revit and I want to demonstrate what the hell are we even creating here. So I have 3 walls here, you can see 1, 2, and 3. And if you look here in the properties, you see that there are multiple layers to each wall. Now, I can click on this tool that I already prepared here, and I'm going to select wall number 1, then wall number 2, and wall number 3. And as you can see, all of these walls were already split into multiple layers. I can even start kind of removing them layer by layer, and you can see there are multiple layers inside of it. Then same one is here, and you'll also notice in here it includes material name and its thickness. And then also here's the last one. I can just go from behind and start deleting all layers one by one so you can see now the wall was split into individual layers. And now let's actually think, how are we going to create such tool? Because as you know, before we're gonna go and start coding, we need to come up with a plan. We need to brainstorm all the steps we need to take so we can write them in code one by one, and then it's gonna be executed and create our desired results. So I'm gonna pull up my PyCharm. This is the tool where we'll be coding during this lesson. And we're gonna write here as comments all the steps we're gonna create. And also, this is the template from my pyRevit StarterKit. This is the easiest way to get started with pyRevit and start creating your Revit tools. I'm gonna leave links in the description under this video. In here, you can see there's some information about the button, such as title and description. Then our regular imports from Revit API DB, and we also need our .NET list. Then a few variables we might need, and in here we're gonna start coding. But first of all, brainstorming. What are the steps we need to create? So obviously, first of all, we need to pick some wall, right? Let's write here first, pick a wall. Then secondly, what do? We pick a wall, then we wanna go and have a look at all its materials. So we're gonna write here, read wall materials. Then once we know about wall materials, we can go and we're gonna create new wall types with material and thickness. Okay, that works. All right, once we're gonna have our new wall types, we actually need to place them, right? So we're gonna create new walls plus position them correctly. Because now we have multiple layers and one is gonna go after another, and we wanna make sure they go in the same order as they should be and also with the right kind of offsets. Now, by this point, we will have our wall created. Now we need to also delete initial wall because we don't want to have overlap with the old wall and all the new walls. So we're gonna delete the initial one. Now, during the steps, there are also a few things that come to my mind that I need to think through. First of all, we need to ensure that hosted elements are copied too. Because if you have a window or a door hosted on your initial wall, you also want to have it in your kind of split walls as well. But also we want to make sure that there's only one door. Now, next after that, we also might ensure that parameters are copied too, because you might have some comments parameters or some other important parameters that you want to see in the new walls as well. So we will think about how to copy this as well. And in the end, also, we need to join new walls together. This is necessary for the host elements to have correct cut opening. Because as you know, if you're going to have multiple kind of walls one after another, but wall is on the inside of one, for this wall to make opening in others, you need to join the walls. This is a little trick in Revit if you work with this kind of split walls, but we still need to address it in the end of this video as well. Now, this is our plan for this lesson. We're going to pick a wall. We're going to read wall materials. We're going to create new wall types. We're going to create new walls. We're going to delete initial wall. And during all of that, we need to ensure that hosted elements are copied, parameters are copied, and that all walls are joined together. So how's that for a plan? And I hope you like it. And let's begin with the first step, pick a wall. So to pick a wall, it's not that complicated. There is a method and selection class, which is called pick object. It takes object type argument, and it needs to be element in our case, because we want to select an element. Now, to use it, we're going to write reference wall equals UI doc selection, and then we're going to use this method, right? So this is going to give us selection related to our project, and this will kind of ask user to actually select a wall. Now, before we continue, let me just quickly show you documentation. So this is Revit API documentation online version. In 23, if I'm going to look here for selection class, then inside there are going to be methods. These are different ways we can select elements in our Revit UI. And there is this pick object, and we're going to use the first one, pick object. This is the method that we need. It comes from Autodesk Revit UI selection, that selection. Right, you might also notice that right here it says unresolved reference object type. This is because we need to import this class. So let's go to our imports. And as usually, we import everything from Autodesk Revit DB, but we might also need to import from Autodesk Revit UI selection. And we're gonna import everything just to keep it simple. In reality, we will need our selection, object type, and eye selection filter later on. But just to keep it simple, let's import everything so we don't have to worry about these imports anymore. And now we're gonna go down, and you can see now it's not highlighted anymore. Now, one thing you need to know is that this is gonna return you reference, not an element. So we need to convert from reference to an element. So we're gonna write selected wall equals, I'm gonna use dog get element, and we're gonna provide this reference wall. Now, let's also make a print statement and just go quickly test it. So I'm going to go to Revit, then we're going to click on the button and let's select some wall, right? Here it says it's a wall, that's great. But also with this code, we can select any other element. Now it's going to be family instance. In this case, it's a door, and that's not what we want. So there are two ways to do this. First of all, we're going to say if type of selected wall not equals to wall. This is the simplest check, right? We need to make sure, is it a wall? If yes, then we're going to continue. If not, and we're mostly interested if not, let's make it if it's not equal to wall, then we're going to, from pyRevit import forms, I'm going to make an alert message. We're going to write forms alert. You have to select a wall. And we're going to exit script to true. Now, to make it a bit more organized, let's move the print statement into print statements right here. So this code will check if our selected element is a wall, and if not, it's going to exit the script and give this kind of warning to the user. Let's go and try it. So I'm going to click on this button and pick one of the walls, for example, that one. And you can see it's a wall, everything works great. But if I'm going to select something like a door, I'm going to get this pop-up saying you have to select a wall. That's one of the ways to do this. This is the quick and easy way to select your wall. Now, there's also another one. It's a little bit more advanced way, but it's also much better user experience. To be honest, it's not that complicated once you understand how to use it. So let's try that as well. I'm gonna comment this out quickly. And for the second one, we wanna use eye selection filter. This is a special kind of interface in Revit API that allows you to filter what can be selected. So when we kind of hover over elements, only walls can be selected. Here's how it works. So let me just make a comment here, pick wall more advanced. And we're also going to copy this number right here. I like to use these emojis. You can pick them by using the window key and dot if you are interested. Now, in more advanced version, we need to create a class of eye selection filter. So I'm going to write class ef wall filter. It has to be based on eye selection filter class. This class comes from Autodesk Revit UI selection, so it's from here. You still need to import it. Once you're going to import it, it's very simple to use this class. We're going to create your own class based on this interface. And now we need to use the method called allow element. You can already see there were some suggestions saying I need self and element. This is sort of predefined method inside this eye selection filter, which need to be modified so it works correctly. Have this variable element here, and we can make any test we want. So we're going to write if type of element equals to wall, then I'm going to return true. That's it. That's the bare minimum to use eye selection filter. We're going to create your custom class, and in the rules, it's going to look at all the elements, and if they are walls, it will allow selection. Now we need to use this filter. We're going to come back right here, copy these two lines. And inside of Revit API documentation, I'm going to show the screenshot. This method can also be used with eye selection filters, and it refers to creating this kind of classes. So let's take the name of the class, which is EF wall filter. And I'm going to provide it here as a new argument. And make sure you actually call this class, right? So you're going to create your custom filter equals this, and then you're gonna write it here. Or you can just directly kind of create it inside the parentheses. That's also fine. Now, we're gonna print selected wall. Let's go to Revit and see the difference. As you saw, with this one, we could select anything we want, but with that one, we're supposed to limit our allowed selection. This is not that complicated, and it actually makes your experience much better. So click on the button, and now I hover over the floor, nothing happens. I hover over the door, nothing happens. But if I hover over the walls, then I can select the walls. So now we can only select walls and nothing but walls. This is great. And it's all based on the class of wall. Now let's go back, and I think I'm gonna stay with the advanced way of selecting. So this one, it's just for you. If you want a quick and easy way to select wall, that works. It's usually that's where I start. But later on, I usually tend to add eye selection filters, so it's more beginner friendly to use my tools. Now we have our selected wall. Just one more thing I would add here. I would make try and accept in case somebody cancels selections. Because if you want to start selection but not kind of select anything, let me just show you in here. So I'm going to start my selection, then I'm going to cancel it. Ooh, I get an error. This is not really an error because the user aborted the big operation. It just notifies us what's happening. I just want to ignore this. So we're going to go here. I'm going to write try. If something happens during selection, then we're going to do something in the accept. And in here, we probably just going to print this one. Let's just copy this form and we're going to paste it here. So you have to select a wall to continue. Yeah, that's fine. All right, the first step is done. Now I'm going to go to the second one, read wall materials. How do we do this? Now, let's just go and actually have a look inside of Revit. Just going to use Ctrl Z a few times so I can see the full walls. This one is fine. So how would you do it manually? This is the question you have to ask as a programmer. And also you have to think about all the ways you can break it along the way. So we're going to select our wall. Then we would like to look at the wall type. This is my wall type. Because inside you see there's a construction called structure. We're going to click on edit, and it's going to give us this menu where we can see all the materials. We can see its function, we can see its material name, and we can also see its thickness. This is what we want. Now we want to achieve the same with the code. So I'm going to select the wall. I'm going to go to add-ins, and then with Revit lookup, I'm going to snoop selection. Now in here, we're going to follow exactly the same steps. This is just kind of internal view of your elements, right? You can see everything that's happening behind, all the properties, methods. This is what programmers need. Now, first of all, I want to look for my wall type. So I can use get type ID, which is right here. Oh, there's also one for this one, wall type. So this is going to return you wall type, and it's only available to wall classes. And the first one is available to all your elements right here, but it's going to return you element ID. I like to use that one because it's more universal. You'll later be able to use it on floors and so on if you need to. Now, so let's click on it, and this is going to open you the wall type. Now in here, we need to look for the structure. As you remember, I think I can still click. Yeah. In here, we're interested in this structure. So where is it? I'm just going to write in the search something like structure, and I can see, oh, there is a method called get compound structure. And that's exactly what we need. So let's click on that one. It opens you compound structure. Inside, I can see right here, there is a method called get layers. So if I'm going to click on that one, that's exactly what we need. So we select type, we select structure, and then we get layers of our materials, which are these ones. And these are the steps that we're going to follow. So first, let's just go here and we need get type ID. Okay, we're going to do exactly the same thing. So we're going to write type ID equals, we're going to take selected wall, get type ID. This is a method, I already know this, so this is how it's used. Now, this is going to give you element ID. We want to make sure that this is actually a wall type. So we're going to write dog get element. I'm going to provide this type ID. Also, it might be a good idea to name it wall type ID. In PyCharm, if you select anything, hold Alt and J, you can select the next instance. And you can also write in the multiple places like this. So if I would want to kind of find all the walls, I would hold Alt, click on JJJ. But also notice that you can select it from the comments, from different variables and so on. So be aware of what you select. All right, so we have our wall type. The next we need structure. For that one, as you remember, let me just find it. We had to use this one, get compound structure. So maybe I can right click and copy this. Let's just go to PyCharm. I'm going to paste it here. So here's the get compound structure. We need to call it on our wall type. So I'm going to write structure equals wall type get compound structure. Just like this. So we have our structure. Now we want to get the layers. And there was layers equals structure get layers. I think that's how it's spelled. But we're going to see. For now, let's just kind of for lay in layers, print lay. Right, let's just make sure that we actually getting something. So I'm going to click here, select on my wall. And I'm getting compound structure layer. Now we can go to Revit Lookup and have a look, or we could also use kind of documentation. In here in the search term, I'm going to put this one, look for the class. And inside I could look at all the properties and methods. I can already see there's material ID, width, function. This is what we need. But for this case, I would probably select it, go to add-ins, Revit Lookup, Snoop selection. And here again, first of all, look for the type. Then look for the structure. Then we need something about layers. This one, get layers. And in here, all of them. I think Revit Lookup is much better because here you can see the actual values. You can see function is finish 2, layer ID, you can see number 3, material ID is plaster, width is this one. By the way, the width is in feet, so we will have to take it and convert into centimeters. Just keep this in mind. Now let's just quickly write all the properties that we might need. So we're gonna write, just call it layer. Then this one gonna be layer width equals layer width. Then layer function is gonna be layer function. Layer material ID equals layer material ID. Okay, I think that's what we need. Material ID, width, and function. I think that's going to be enough. If not, we're going to come back later and take something else. So let's go back. Now we have all the layers we want. We have their width, and this width in feet. This is important. I want to have my width in centimeters. So I'm going to use unit utils class. There is convert from internal unit. I'm going to take this layer width, and we need to provide unit type ID, and I'm going to convert it to centimeters. You can convert it to any other values if you want to, but this is really a useful step. Now, another thing here is the material ID. As a programmer, you should always think about how can you break your code as you write it. And in here, I had an idea that let's just go back to our wall, look at its material. In this case, they're all materials defined, right? I have material here, there, and so on. But what if you create a new material? So I'm gonna click here, insert. I'm gonna give it the thickness, I don't know, maybe 50 millimeters. And I'm not gonna assign any material. What's gonna happen, right? This is really important to have a look. I'm gonna click on OK, OK. Now I'm gonna click on that one and click here. Now we also need to make some print statements. So let's just write here, print layer material ID. But most importantly, this is element ID, but we want to have layer material. This is gonna be dog get element. I'm gonna provide layer material ID. Let's also print that one. Oh, in PyCharm, you can use Ctrl D to duplicate your lines, Ctrl X to remove them. Now, let's just go test it and click on that one. And here you can see some number, material, -1, none. So this one is the layer where there is no material. And it's important because later on when you're gonna say, you know what, print me material name. Now I'm just gonna go here, click, okay, material name, and then this happens. Non-type object has no attribute name because we did not get any material. Now we cannot read any of material properties. The reason I'm saying that is because we need to address it right now. So we need to create here some kind of if statement. There are different ways to do this. In our case, we're getting material ID and we're converting it into material. Now the material name, there are different ways to do this. I'm gonna do the following. I'm gonna write layer material name if layer material else, and then we're gonna provide some name like generic maybe. Yeah, generic I think is fine. You can also write empty. Here's what's going on. This is called if statement comprehension. It's like list comprehensions, dictionary comprehension. You can also put if statements together. The same we could write if layer material. So if here we get anything but none, which is important, then we could write material name equals whatever it is, layer material name. Or else material name would be generic, right? It's exactly the same thing. I prefer to have one liner because I like to keep it very simple and readable in my Python code. But you can do as you wish. Now let's write here get material name. This was read layer properties. And maybe move that one here. I think it's more in this category. All right, so we got our material name and we got our properties. Why do we need them once more? And this is because, well, we want to create new wall types and we want to make sure that it uses material name and also the thickness. This is exactly what we got here. This is our thickness in centimeters. This is our material name. Or it's also going to be generic if there are no materials assigned. So the next step is going to be, let's click on window key and dot, number 3, and I want to make like this. We're going to create new wall type. Then I also forgot here, I want to make an emoji too. So make it number 2. Read material names. This is kind of part of the step number 2. Now we're going to create new wall types. And another important thing, again, we have to think as a programmer, how can we break it? Let's imagine that we run our tool and we create bricks 10 centimeter wall. But then we select it again on the next run. And there we have an issue. We're going to try to create the same wall that already exists. So instead of just creating new wall type, we need to get existing wall type or create new wall type. This is the thing, right? If it already exists, there's no need to create one. So it's 2 in 1. And first, we're going to try to get existing. This is much simpler one, so why not? So let's just get all wall types. And for that, we're going to use filtered element collector. We're going to provide doc of class. Then there's a class of wall type. We could also get by category and then use where element is not element type. But this one is a little shorter, and I know that it's pretty much going to give me exactly what I need. Now let's convert it to a list of elements. And listen, these are just the methods of the filtered element collector, right? If you are new to filtered element collector, I have a really good chapter inside my ebook, which you can download under this video. In there, you will see this filtered element collector anatomy, and you will see how easy it is to use it. You pretty much always use of class or of category. Sometimes you add filters, and that's not that complicated, trust me. Once we have all our wall types, we want to convert it into a dictionary of wall types. The reason for that is because I want to create a dictionary where I have the name of the wall type and the actual wall type. This way, it becomes very simple to check, is there a name like this inside my dictionary? If it is, give me the type. If not, then I do something else. So let's make a dictionary here, and I'm going to use dictionary comprehension because I just love keeping everything on one line when possible. In here, we need to make a loop for wall type in all wall types. And then before that, we need to define what goes. We need to define key and value based on this kind of wall type. So we want to use wall type name and wall type. Also, I'm going to go one step ahead. This is going to give us a warning in pyRevit for some reason. Even though there is a property name in wall type, we cannot read it this way. I still don't know why. It's a bit confusing to me as well. But instead, we can use element name get value wall type. Right, this kind of internal getter of the value of your properties. And since it's based on the element class, this is how it works. Trust me, this is how you get your wall type. Again, if dictionary comprehension looks over the top, let me just quickly make this similar one. I'm going to call it quick, but it's going to have the same meaning. So we're going to write first for wall type in wall types. I'm going to paste it here. Then we're going to get our wall type name, which is going to be this part right here. Then we're going to take the dictionary and we're going to use, this is the wall type and it equals to wall type, right? So these are exactly the same things. This takes 4 lines of code, this takes 1 line of code. And to me, once you know how it works, it's not that complicated. Okay, your key is this, your value is this is the loop you're creating. And the result is going to be your dictionary. Same thing here. Let me just comment it out. I hope you had enough time to see it. Otherwise, just pause the video. I'm going to hide it like this. Now, where we are creating dictionary of wall type so we can get the right wall type. Now we need to define our kind of wall type name because we need to know what are we looking for or what are we creating. So it's going to be wall type name. I'm also going to create here something like new to refer to the new wall types that we're creating, like all new walls we're creating inside of Revit. This is going to be easier in the code. Now we're going to keep it very simple. I'm going to take name, and in parentheses, I'm going to add in centimeters the thickness, right? The width of this layer. With format, we can provide a material name, and somewhere there we have this layer width in centimeters. So the format is very simple. In here, you create two placeholders, or as many as you need. And then you say material name is going to go right here into that one. And layer width is going to go right here into this placeholder, right? This is an easy way to combine your strings together. Now we have our new name. Now we can check, is there such wall already in our project? So we're going to write here, if new wall type name in dictionary wall types. When you make it like this, it's going to check, is it already in the keys of the dictionary? And if it is, then we want to get our new wall type equals, it's going to equal dictionary wall types, and we're going to get it by using this name. We're going to only execute it if it's already inside. Otherwise, we would get an error if you would try to read something that's not in the dictionary. This works great. Now, what do we do else? So this one is simple. It's going to get existing wall type. However, if it's not there, we're going to create new wall type if doesn't exist. How do we do this? This is the question. One of the easy ways to do this is to just duplicate existing wall type. I just quickly go to documentation. I'm gonna look for the wall type. Let's open all the methods. And I know that there is, if you would try to look for something like create, we can scroll through. There is nothing here. But I know that there is a method called duplicate, and it's right here. Duplicate an existing element type and assign it a new name. That's perfect. That's exactly what we need. Why not? So the way it works, and if you look at the syntax, this is the name of the method, and we can call it on our element type. You can see it comes from all element types. So we're going to duplicate it, and we need to provide a name of a new wall type. And then in here, you can see this is what is going to be returned after you use this method. So we're going to get element type, in our case, wall type. That's all okay. Let's just go and say here, you know what? New wall type. And also make sure you use the same name, because later we're going to reference this variable. What we do, we're going to take our existing wall type, which is right here. This is from the existing wall. And we use duplicate. And we're going to use the name. So normally I would do something like this inside of the try statement, because if you're not using unique name, then you're going to get an error. However, in this case, that's quite fine because we already checked it here. If it exists, we would just use existing one. If it doesn't exist, only then we're going to create it. All right, we have our wall type. What's next? You know, in programming, when you're not sure what's next, let's just go back and try to do it manually. You know what? I would click here. I would click on edit. I'll look at one of the materials. For example, I need concrete 100. Okay. We're going to click on duplicate. We're going to call it, you know what? It's going to be concrete 10. And like this. What is the next step you do naturally? And you might think like, oh, actually, I would click on structure and obviously adjust the materials, right? So I'll remove that one, that one, that one, and that one. Okay, so adjust the materials, name is correct, and then I would click OK. I would also maybe adjust something here, but since we're duplicating, it's going to be exactly the same. No need to worry. And that's exactly the thing. We need to assign the same materials. How do we do this? As you remember, let's go to documentation. I'm just going to look for get compound structure. Yeah, this one, get compound structure. We use this method to get our compound structure of an element. So let's get it and see how do we create a new one, how do we change it or whatever. In here, as you remember, we had there get layers. And when you have something like get layers, you can also set, is there something like set layers? And you can, there's actually set layer, set layers. So one way would be to get the structure and then set layers to something else. Okay, that's good. But also, how do we create a structure? We could take existing one and then clear it, but probably there is something to create. So let's search for the create. Let's just scroll through and see. Okay, there is right here 3 methods. Create simple compound structure, create single layer compound structure, okay? And then create single layer compound structure. So there are 3 different ways. We can read right here difference, create non-vertically compound structure, comprised of parallel layers. This is pretty much what we need. This one compound structure containing only single layer, that also could be this. And then create a vertically compound structure with 1 layer. So we could use pretty much all of them. Let's just see what's easier to use. And now already can see that this one takes only a list of layers, which is great. This one takes you sample height, layer function, width, and material. That's a bit too complicated. I don't want to see this. This one, you need layer function, width, and material. In our case, this one is the best because in here we provide a list of layers. We can already kind of use existing layer. Because if you remember here, we say for layer in layers. So we already have a layer. That's going to be very simple to use. So let's use that one. So I'm going to copy the method. And then in here, I'm going to say something like right here. Adjust materials structure. I'm going to create new structure equals. And then in there, we need to write compound structure, create simple compound structure. If you wonder where does this come from, let's go back to documentation. This is a method, right? So you can use it on your existing instances or sometimes classes as well, if it's a public one. In this case, you can see that this method called create simple compound structure comes from this class, Autodesk Revit DB compound structure. So we take this class name and we add this method name right here. Then we can use it. Now inside we need a list of layers. Sometimes we can also get away by giving the Python list. Sometimes it works. So let's try this. We already have our layers. So we're going to write list layers equals a list. And we're going to add our layer. So I'm getting this layer right here from 4 layer in layers. We're just going to create a list of layers. Even though it's just 1 layer, it still has to be a list. And then we're going to provide it inside there. Okay, I think that should be good. So we have our new structure. Now we need, how do we change the existing structure? We're going to go back. And Revit API, there is this logic. Usually when you can get compound structure or get, I don't know, width, get whatever, like get something, usually there's also going to be set something. In this case, there is set compound structure. This is great. So the same way we're going to get it, the same way we're going to set it. You can see it takes here exactly the same argument, which we get from this one. So set compound structure, and it has to be used on the wall type. So new wall type, set compound structure, and we're going to apply our new structure. Now, before we're going to continue, I want to test this. I want to make sure that we are creating our wall types correctly, or that we are getting them. So the way we're going to do this is we're going to go to Revit and we need to test it. But also, if you already know Revit API pretty well, you know that we need transaction. Because the moment I'm going to try to make any changes, I'm going to get this warning, attempt to modify outside of transaction. Nothing to worry about. We're just going to go and, you know what, I'm just going to make it in the beginning, right? Transaction. Let's add here emoji of some lock. We're going to unlock it. We're going to T equals transaction. We need document and name of the change. It's going to be split layers, split wall layers. Yeah, that's good. We're going to start it. Then we need to commit it. And as you know, changes should be here in between. So in our case, we just take commit and move all the way down, right? So we don't have to worry about transaction. Now let's just add some emoji. Here we open the lock and here we're gonna close the lock. Right, that's good. Now let's just see what happens. So click on that one, select the wall, and I didn't get any errors, so this is already a very positive sign. I also forgot to make any print statements, so let's just go and do that. So we're gonna write print new wall type. Yeah, like this is fine. Now, if I'm gonna click here, click on that one, I still didn't get any print statements, and this is correct because probably I already created it before, so now it gets it right here by getting existing wall layers. So I need to test it differently. I need a new wall. So I need the new materials. You know, I think I'm gonna just try to find something new. I can already see here there's the names of my materials with the thicknesses 7.5, 5 centimeters. Let's just find something like, I don't know, I think that one might be fine. So let's just click on that one, select this, and then we get this one. We get two wall types, we create two objects. I'm gonna click on that one. Let's see inside. We need to look for brick engineering and brick engineering solder cores. So we're gonna go and have a look. Do we have something like brick engineering? Yes, it's a brick engineering 21 centimeters. Let's go to that, have a look here. Inside it's 215 millimeters, that's great. So everything seems to work as long as this is the right thickness. All right, so this step works. We already creating new types or we're getting existing ones, which is really, really important. So this was this one, create new wall types with material and thickness, right? Let's remove it. The next one, we need to create our walls. Let me just make here emoji, number 4, create new walls and position them correctly. So there are different ways to do this, and I'm just gonna go one step ahead as well, just to save us some time. And you see this, ensure that hosted elements are copied. The easiest way to ensure these 2 points, so you keep the same parameters and you keep hosted element, is to duplicate existing wall. I'm gonna take this wall, the comments is gonna be EF wall. I'm gonna take it and copy that one. It's gonna remember it's all the height, all the levels, it's gonna remember the comments and so on. So if I select it, it's gonna keep all the comments. The mark parameter, this one, it's not gonna keep it. If I'm gonna make 155, then duplicate it, you notice that it's either disappears or it can also increment sometimes. So it will be 156 sometimes. But this one we can fix, but majority of parameters and stuff is gonna be exactly the same, which is exactly what we need. So we're gonna go this route right away. Alternatively, you could sort of kind of create a new wall in the right position, then you move your door. You also need to make sure it's in the right position, make sure it has the right levels. You know, you can already see how much more harder that would make our life. So we're not gonna do that way, we're just gonna duplicate. How do we duplicate? So let's come back and see. So let's go to documentation and I'm gonna look for copy elements. All right, there are already a few methods here. Let's click here and you can see there are 3 different methods. Copy set of element and places copy at a location. Then this is from source document to destination document. So no, this is from view to view. So the first one is what we need. Takes a document, list of elements to copy. Now, in our case, again, we need to create a list of a single element. And we need translation. This is like a vector from where to where. If you've been here and you give a vector, I don't know, like XYZ 550, you move 5 points right, 5 points up. This is your destination point. So this is what we're gonna do. It's also located at element transform utils. So what we're gonna do is, let's just copy here. So element transform utils, copy elements. Then we need our document, list element IDs. And I think the last one was vector. It's called something different like translation, but vectors, points, translations, they use the same class XYZ, which is just a coordinate. What's important is here, return IDs of newly created copied elements. That's great. So we can assign it here, new element IDs. I think it's going to be IDs. Yeah, you can see it's going to return you a collection of element IDs. All right, so let's just go and make it happen. First of all, we just gonna paste it anywhere, right? The vector, this one, we're gonna make it simple for now. We're gonna focus on it in a moment. We have a document, we need a list of element IDs. For that, we're gonna take our selected wall and we're gonna make a list. So list L IDs equals selected wall ID. That's enough. I'm gonna try to provide that one and see if it works. And for the vector, we're just gonna write 10, 0, 0. Let's see what happens. They all gonna be in the same place, but let's just see if we duplicate it correctly. Click on that one, click here, and we get an error. That's okay. Expected I collection got list. So whenever you see expected I collection, you need to use specific .NET typed list. We already have it in our code. It's right here. This is how you import it. This is important. You need CLR, so you can reference system, so you can import from system collection generic list. This refers to iList, and it can also be used instead of iCollections. The way to use it is, I like to use it capital list element IDs. It's going to be list of your specified types, and then we use parentheses. So in here, it has to be list of element IDs, and in here, we're going to provide our list, Python list. This way, the Python list is going to become .NET list. The difference is in Python list, we can add anything. We can add number, text, list, dictionary, whatever. We're not going to get errors. In this specific list, we say that this list can only contain element IDs. So there's like a security checking, like, is this element ID? Then go in. If not, raise an issue, say, hey, you cannot do this. Then let's make sure we provide it here. Now we click on that one, we select the wall, and you can see there are identical instances in the same place. That's okay. Well, the point is that we are managing to duplicate it, right? We're just taking the existing wall and we're making 3, 4, 5 copies. 5 because we probably have 5 layers. 1, 2, 3, 4, 5, right? So we iterate for each layer. In this case, we kind of duplicating it. Right away, let's just apply new type. So where we are. So here we're getting a list of new element IDs. It's safe to assume that wall is going to be always the first one, because that's what we're duplicating. At first, I also thought that it's going to include doors and windows in this list, but for some reason it's not. It's only a list of a single wall. So therefore, our new wall ID is going to be new element IDs, the first thing. And new wall is going to be dog get element new wall ID. Now, once we have our new wall, we're going to take new wall type equals to our, where it is, new wall type, right? Either existing or the one that we created. Also, we don't need this print statement right here, so let's put a hashtag. So we have our wall type, and now we want to also change its location. For now, let's just kind of quickly copy and see if we are assigning the right wall types. So click on that one, click here. You can see we put it somewhere, but it's already great because I can see different thicknesses. They're all in the same location, but that's not the point. Now you can see a bunch of different elements inside. This is great. Oh, by the way, let me just quickly explain you what I have. So let's search for the wall class, property, wall type. This is the type that we are changing, and in documentation you can always see get and set. So get means that it's a readable property. You can get your element and you can read it. Pretty much all properties are readable. Otherwise, they have very little meaning. But sometimes you can also see set. It means that you can also take your wall. Then you take the name of your property, which is going to go here, which is going to be wall type. Sorry for the height. Sorry for this horrible writing, but you get the idea. And then we can apply it. We just say equals to whatever, right? Our wall type. Because it says here set, we can do this. Now let's go back. All right, so we're setting our wall. Now we need the location. There are different ways to get the locations. The simplest one would probably be take your existing wall, because it can be rotated in all directions and so on. So this might get tricky. But if you're going to get your existing wall, which is, let me just show you, this one. We're going to get its kind of line, which is right here in the middle. And then we're just going to calculate the offset, because there is probably a method to create an offset to the line. Then we're going to create a new line and we're going to assign it to a new wall. That's our plan. So to create an offset, there is obviously create offset method. Very straightforward. It's part of the curve. So first we get a wall, get a curve, we create an offset. It needs reference vector, and it needs also the number, how much you want to offset. So for this one, we're just going to give z-axis. So we know that this goes up. So we're kind of moving in kind of this direction. Let's just do this. So somewhere here, we're going to define new location. So first, we need to get the current curve. We're going to get it from selected wall, location, curve. The new curve is going to be curve create offset. As remember, we need our number and we need our, what was it, x, y, z, z. So you need to specify kind of what is the axis. In this case, kind of just z is enough. It's just up, down. Then it means that we're moving in these directions. All right, so we have a curve, we have the offset. Now we need the right distance to the offset. So calculate offset. That one actually is a little bit tricky because first of all, we need to remember a few things. Let's go before here. We need some extra variables right here. So I want to get my total thickness of the wall, and we're going to use wall type width. Then we also need to kind of remember where we are because we're going to start here, but then we need to remember how much and which direction we move. We're going to write here current offset. We're going to start with 0. Now also that one is not really necessary. We can just call the wall type width like this. So we just need to create this current offset. Now let's go somewhere here and we need to write the following. I'm going to say offset equals, then I'm going to take wall type width. Then we're going to minus layer width. Make sure it's in the feet, not in centimeters, because in Revit API, we work in feet. This one divided by 2, because I'm going to use the center line for creating my walls. Therefore, we only need half the width, right? So we start here. If your wall is 10, the center line is going to be at 5. All right, that's good. And then we need to minus this current offset. I think we need to multiply by 2, right? So depending on how we're going to add it in the end, but I think that's going to be enough. Now, and we also need to put it in parentheses and divide it by 2. This one is probably the most confusing part of this code because it's still confusing to me. I know it works, so I'm just going to write it, but I'm not going to go in depth explaining it because you need the center line and you also kind of will be remembering the current offset, which is just going to update in a second. So just know that this should work. And to make sure it works, we're going to take the current offset, which is going to be right here. I'm going to write plus equals layer width. So this way, we're going to be adding all the layers one by one. We start at the 0, then the first layer is 10, we're going to add 10, second layer 5, we're going to add 5, so we can see how far we went along the wall type. Now, this is going to go to calculate offset. Here, there is also a quick one. If not, selected wall flipped. So we need to check is the wall flipped or not because we need to know in which direction we move. If it's not flipped, we might need to set the offset to minus offset. Just a tricky part that might solve some issues later on. And offset curve is going to be selected wall, location, curve, and then create. And then once you have this offset, we're going to take the curve. I'm going to create a new offset curve. So in here, we're just going to provide the offset. So let's just kind of recap a little bit. So we calculate our offset, we define new location, which is going to give us a new curve. Then right here, we are duplicating our wall. And it doesn't matter where we duplicate it, right? Let's just remove this vector. That's going to make here xyz 0, 0, 0. Or maybe 10, 0, 0. It doesn't matter. Because the moment we're going to duplicate it, let's just write here, duplicate existing wall. This is going to get new wall. We're going to get new wall. We're going to assign new wall type. And we're going to assign also a new location. For that, we're going to take new wall, location, curve equals new curve. Right? Adjust new wall type and curve. Yay. Whew. All right, this is probably the most tricky part of this code to just make the right offset and kind of duplicate it correctly. I think that should work. So let's just split on it. We're going to select the wall. You're going to get an error. Let's just see and solve it. Expected XYZ got something else, 130. Oh, it's this one. So it expected XYZ, but I gave it Z, which is the name of the property. It should be basis Z, right? My mistake. This basis Z is pretty much the same if I would give a thing like this, right? It just creates the direction of a vector. But let's just use basis Z. Now we're gonna try it again. Let's see, oh, that's a good sign. We created a wall. So I can see there are lots of layers, but I also have my existing wall. So maybe that's also a great moment to kind of get rid of the existing one. So let's just go one step ahead, delete initial wall right here. So we're gonna say dog delete. I'm gonna take selected wall, id. Just add here fire emoji, and we're gonna try it again. Click on that one. So highlighted walls overlap, one of them might be ignored. Okay, we're gonna see what's going on. Now let's see. So there's something wrong about the spacing I can see. We did not calculate something correctly. We're gonna fix it in a moment, but now you can see everything is fine. It works. So I definitely made a mistake with the offset somewhere. This is what we need to solve. But so far it looks good. We creating new wall layers, we naming them correctly, we even creating them almost correctly. And yeah, let's just go and try to figure it out. I'm just gonna do it once more just to see, does it go outside? I can see that my lines are here. If I cancel it and bring my lines back, yeah, so it comes out. Something wrong with the offset line. I'm gonna come back here and I'm just gonna try to figure it out first. All right, I'm just looking at the code I'm using as a reference, and this is not supposed to be here. This part is not written by me, it's made either by Mohammed or Joven, because I don't hate to go into this math. And if it works, why change it? Let's try it again. Flawless. Now it works. As I said, this is going to be the hardest part of this code, is just to calculate this offset. It's a bit confusing here, but it works, and let's just ignore what's happening there. I'm going to click on it, click here. Now look at that. It just splits beautifully into all these extra new layers. It names the wall types correctly. We have all of them, like brick common 1025 centimeters. This is great. One thing we might notice is that now we have lots of doors, because now each layer is going to have its own door. This one has a door, this one has a door, and so on. So we need to define where our door stays. So at the moment, let's just take that one. If I'm going to duplicate a wall, the door comes with this. And this is great because it's going to keep all the parameters, location. We need this. But we want to make sure that only the first door kind of keeps its location. So how do we do this? And the way it's going to be very simple. This code is getting so big, it gets a little harder to navigate. But just go to your layers. We need to define, is it the first or the last layer, right? Probably that's going to be the most logical one. So I'm going to add here n layers in enumerate layers. The way it does it, so if before that you got your list of layer 1, layer 2, layer 3, layer 4, right? So before that was your list. And now with this enumerate, what it's going to do, it's going to add the counting, right? So this was item 0, item 1, item 2, item 3. And we're going to get them as tuples, right? So this is tuple number 1, tuple number 2, and so on. So in here, when we iterate, this is going to have the number, is it 0, 1, 2, 3, and so on. This is going to be the actual layer. This is the easy way to calculate, kind of count your iterations. Then somewhere on the bottom, where we're going to duplicate existing wall, get new wall, adjust new wall and stuff, somewhere here in between, we want to remove duplicated hosted elements, if any. Now, so first of all, we're going to decide if n is not equal to 0. Yeah, that's going to be the easiest one. If it's the first one, we're going to keep it. If it's not the first one, we're going to delete it. So we're going to get dependent elements. To do that, dependent IDs equals new wall, get dependent elements, right? I think that's how it's spelled. Let me just quickly get dependent elements, and inside we need to provide a filter, but it's an optional thing, right? If you're gonna scroll down in parameters, it tells you what type of elements we are interested of, can be null to return all dependent elements. That's great. Let's just add here none. All right, so one problem is I need to make it after I get a new wall, because here is the variable new wall, we need to use it. All right, we're getting our dependent IDs. Now let's just write here something like hosted elements, and it's gonna be an empty list because we're gonna for element ID independent IDs. First, we're going to get an element. So let's convert it to an element because we need to make one test. Because you see, it will return the wall itself as well as dependent element, which can be annoying. So we're going to write if type of element, what is it? What is it? Not equal to wall. Because we want to ignore the walls. We don't want to delete the wall itself. Then we're going to delete this element. So then doc delete, and we take this element ID, right? All right, let me just add here, remove hosted elements, unless first wall. All right, this should be it. Just go to Revit, get back to when we have the full wall, right here. You can see that's a single wall. Let's just select it and click on this. Getting an error, something is not right. Wall object has no attribute get dependent elements. So I misspelled something, or I used something wrong. So let's just see how it's spelled. Get dependent elements. I had a feeling that I misspelled it. Oh yeah, here, dependent. Yeah, right here I have a typo. Should be like this. Let's see if it works. Click on that one. Perfect, it works. Now how many doors we have? I select like this. Perfect, we just have one door. That's exactly what we need. Now notice that there is no opening here, right? To simplify the explanation, let me just remove a few extra walls. And in Revit, when you have like a wall, it has an object which has this kind of void to cut it. If you're gonna join the walls, right? I'm not joining the door, I'm joining the walls. So click on join. If I join these two, you can see the opening continues. So now we can actually go and think about how do we join all our walls. I'm just gonna go here, number 6, join new walls. Let's make it like this so it's easier to follow. And also we forgot here to do the same. So ensure that hosted walls copied. We got that one. Ensure we got that one. Join new walls together. Obviously, this is what I mentioned to you. Now, how do we do this? Obviously, there are different ways to do this. We need to use join geometry utils. And then there's join geometry. It needs document, element 1, and element 2. In our case, wall 1, wall 2. Just to keep it simple, I'm just gonna write wall A in new walls. Oh, I think I did not create it. Yeah, I need to remember all my walls. So somewhere before the iteration begins, I'm gonna create new walls equals empty list. So somewhere here we select a wall, we create this list, then we iterate for layers, create a bunch of different walls, and we want to add them somewhere here, new wall. So here we're gonna write update offset and new walls list. So for wall A in new walls, then I'm gonna write for wall B in new walls. Not the best syntax, but it's gonna be quick and easy. Now we're gonna just try to join them, right? We're literally gonna try to join all walls against each other because we're not gonna have so many of them. We have 5. Okay, we're just gonna join. It's gonna give us a warning, which we could suppress, but for now, that's okay. We'll just add here try and accept so we don't have to worry in joining the same wall to itself because it would give us an error for sure. And I'm not even gonna print any errors. Oh, it should be wall A and wall B. All right, this is just a quick and dirty way to join them. It will work, I think so. Well, we're gonna find out. All right, so click on the button, click on the wall, boom, we created a bunch of them, and look at that. Didn't even get any warnings in Revit, and now it works perfectly. Now I can also just come in here and just move them all apart a little bit just to see what's going on. Right, and here all the layers of the first existing wall. Now it's not cutting because they're not touching each other, but if I would go back, you can see it works. So these were the steps, and I know this lesson got so much longer than I expected because there were actually more things to explain to you. But I hope it was useful to you, and now we can see. The way to do this is first we pick a wall, we could make it quick and dirty way to do this, we could also make it more advanced. We could read wall materials, then we iterate for all layers, we get some layer information here, then most importantly we need to get material name, because sometimes we don't have material, so we need to address that right here. Then we create a new wall type name. And firstly, we need to check, can we get it existing, right? Maybe we already made it before on another wall. And if not, then we're going to create a new one right here. I'm going to set the same layer, so it's exactly the width that we need. Now in here, then we're going to create new walls. And for that, we need to position them correctly. This is the trickiest part because we had to calculate this offset. And again, thanks to Mohammed Beder and Joven Mark, they made the most of the steps here. I just corrected a few in the end about kind of duplicating and saving all properties, and also kind of refactor the code. So it's a bit easier to teach you. Then here you can define new location, duplicate existing wall, get new wall, remove duplicate hosted if any. Then we're going to adjust here the new wall type, which is important. We forgot to do it at the beginning. Then we update these values because we need them over and over in iteration and later on. Obviously, we need to remove the initial wall and we join all walls together. And now it works perfectly. So guys, I hope that this was really useful and you learned how to create such tool and you learned something more about Python Revit API or pyRevit. And if you also want me to see how to refactor this code, how to create lots of different functions, maybe even class, just comment below and let me know if that sounds interesting. I could show you how to rewrite this code to make it a little bit more appealing, so it's more readable and easier to maintain in the long run. And in general, if you're new on the channel, my name is Eric Fritz and I teach people pyRevit and Revit API. You can learn more in my Revit API Beginner's Guide ebook, which you can download absolutely for free, or you can also explore my course platform. Soon I have a course coming, pyRevit Hackers Basics, which is going to teach you everything you need to know to create your own custom tools. I wish you happy coding, and I'm going to see you in the next videos. Goodbye. Ciao.